Okay, do you see it clearly?
We see it. Thank you.
Okay, so thank you very much again to invite me to this nice seminar. A few words about myself. My name is Alessio Gomira. I'm a senior researcher in the Norwegian Research Center and also scientific coordinator of the North Atlantic Microplastic Center. Today, I'm going to present you a little bit the status of the air quality in the Bergen area in relation to plastic pollution related to a project that we had a couple of years ago, plus some updates coming from a recently closed European project. So a little bit of an introduction about the project. So the project was founded with the coordination and cooperation with the Bergen municipality and the Norwegian Research Center, Climate and Environment Department, and founded by a regional fund called RFF Westland. The main objective about this specific project was to acquire basic knowledge about the quantities and distribution of microplastic in urban environments, and also, of course, according to the results and the data and the baseline, form a future reference and a knowledge base for targeted plastic strategy at the local and the national level. And of course, try to anchor and to link with the future strategies associated with the characterization and the reduction of plastic pollution. In terms of urban environments that we have been mapping, within this project, we did a kind of a comprehensive mapping related to different types of emission. We analyzed the sewage treatment plants, the biogas plants in terms of plastic accumulation and occurrence and characterization, sand traps and street swiping, artificial turf pitches, playgrounds, popular hiking trails, and this also air from busy roads, which is the topic of this specific conference. Overall, I need to tell to you that the project per se was focusing more on the micron-sized fraction of the plastic, so everything below 1 millimeter was characterized across the different activities of this project. But now let's step into the air quality analysis. In terms of air monitoring, well, we used a pre-existing monitoring plan organized and developed by the city of Bergen through the environmental health protection, where basically in the area there are 5 stationary air measurement stations, and from them we collected the sample from 3 specific ones. So the purpose was to evaluate if it is possible actually to use the pre-existing monitoring grid to add an additional layer of investigation through the microplastic pollution in the air. A little bit of detail about why we decided to go for these 3 sampling sites along the 5 that were available in the municipality. We identified Rodalen in the south, where there is a monitoring station near a road that represents what we classified a moderate high traffic density, and with a large influx of stone particles, as there is an extraction site over the area, with the possibility of increased airborne particles within a size of 10 micron. The second one was Roland, in a suburban station north of Bergen, which measured the air quality for low traffic areas, and it is located approximately 500 meters away from the waterway, something that we classify of a kind of low impact, at least in terms of plastic pollution. And of course, a site downtown in the city, heavily affected by the road traffic, and then with the possible classified as high impacted in terms of plastic pollution. So this was like our playground. In terms of what we did in terms of sampling and sample procedure, as I told you, we have been using the same type of sampling device that we have been, the municipality is using. So we have been replacing part of the equipment, trying to avoid the contact with the plastic material, piping, filter holder, and then we also replaced the filter that we used for the analysis. Instead of using the polyethyl sulfonate type of filter, we have been using fiberglass filter. A fiberglass filter with a specific mesh size opening of 1.2 micron and a diameter of 47 millimeter, which was basically placed on an aluminum-based filter holder. You have some pictures here about the position and how was the filter position and how it was looking like after the filtration activity. The filter was left into the equipment for 3-4 weeks during the winter months. In terms of sample preparation, remember, microplastic analysis is a pretty young type of research activity, so we had to modify and adapt some sample preparation in order to be able to degrade all the different organic matter expected to be in the filter, but preserve the plastic composition in the same filter. So no strong alkali or strong acidic treatment, simply a very mild enzymatic oriented type of degradation to selectively digest and reduce the contamination of specifically given organic chemicals, because at the end of the process, we need to analyze this type of sample with instruments that basically are referring to organic chemistry. So after degradation, the resulting digestate has been like density separated in order to let the resulting and remaining plastic to float into the upper layer of the dense solution. That layer has been filtered, pre-concentrated, and submitted to the chemical analysis. And of course, as we were like expecting a very low concentration of a plastic in this filter, this type of filter has been like processed and analyzed on a specifically dedicated area of the facility dedicated to the plastic pollution. This is what we call ultra clean plastic lab. It is a lab where all the plastic contamination has been reduced to a minimum, and it is somehow the optimal environment where to open the filter, process the filter, analyze the filter without having, any possible risk of contaminating the sample while processing it on a simple open area chemistry lab. In terms of polymer characterization and quantification analysis, we combined the two most promising analytical technique associated with the plastic pollution, which is like the spectral vibro microscopy oriented methods through micro FTIR imaging. And then, of course, after the scanning of the deposited filter, do the same type of analysis, crunching the filter, and then analyzing the thermal degradation through pyrolysis GCMS. Some background information before presenting you the results. Remember that we have been sampling over the winter period, which we consider perhaps the most worst scenario, especially because in January and February in the Bergen area, there's a lot of particulate matter floating in the air because of the stagnating air and also the heavy traffic that is normally affecting the area during the winter period. So, these are the results that we obtained from the 3 different sampling sites. We also compared the results through the blank. So we have been somehow analyzing the equipment that we used for the sampling of the filter, because remember, this stationary meteorological sampling equipment is normally made a lot with the plastic material. So we were also monitoring a little bit what was like the possible contamination coming simply from the instrument, and then compared against the results that we obtained after 3 months of filtration in field. You may see that the structure and the polymeric composition of the different samples is pretty similar across the different sites, but there is a different relative and total abundance of the given polymer. It's not actually, well, it was a surprise to see car tire particles trapped into the filter, because we were not expecting to see high density polymer basically floating in the air, but actually we were able to document it. And of course, the second surprise was like the small particles, car tire particles, were one of the highest fraction in the air as collected through the field from the air sampling equipment. This comes together with the polyethyl sulfonate, polyurethane, polysulfone, polystyrene, polypropylene, and polyethylene. There is a mixed use of this kind of polymer. Some of them are specifically used in application for construction, buildings. Some other are more industry related to filtration technology, and other are basically multi-purpose type of polymer that are basically assisting ourselves in our everyday life. So with the packaging, plates, cutlery, disposable cups, and so on and so on. Together with this kind of reporting about the masses, normalized to a cubic meter of air filtered through the filter, we also did some reporting about the possible dimension, because this is the beauty of using different type of analytical techniques. So through the microscopy, through the infrared microscopy, we were able actually to localize all those particles, and then we were also able to classify them in terms of shape, size, polymeric contribution, and relative abundance. As you see here, and it is also perhaps worth to say that this has been collected according to the type of equipment we had available at that time in the lab. We are talking about particles in the size range of the near micron size, but this is also basically at the limits of the detection of this specific instrument that we used. To refresh you again, it is the micro FTIR equipment. So our observation and our expectation is there is way more plastic material in the small micron size range, and also in the nanometric plastic particles size range. In conclusion, the study, at least this specific study about the Bergen area, showed that there is a lot of contribution from the car tire particles, definitely related to the traffic from the suburb into the center city. The concentration were observed in the city center compared to the suburb, despite the fact that the city center streets are washed and brushed more often. There is a little bit of discussion across this project about what has been suggested in terms of measurements, and of course increasing the street swiping per se. It is a good way to reduce also the general distribution and flux of plastic across the different area of the urban environment. So the results may indicate a spread of plastic that can be limited by cleaning highly polluted and trafficked area for more frequently. Together with this, we also I would like also to present some more recent analysis that we did within a European project called JPI FACTS, Fluxes and Fate of Plastic in the Northern European Waters. Per se, this kind of project was trying to increase the knowledge and improve the mechanistic understanding of the sources, transport, and occurrence and fate of small plastic in the northern marine environments. Then you may also ask, why are you talking about marine environments? It's because the project per se zoomed into the Byfjorden, so again the city of Bergen, where different type of analysis has been done in the water, in the biota, but also in the air. So what this specific project was speculating at the beginning was looking at the geographical map of the city. If the urban bridges that are connecting the city with a different island and a different other part of the region may be a possible massive input source of plastic in the aquatic and in the air environment. So, may contribute with atmospheric pollution, with the urban pollution and aquatic pollution, and of course, interact all of them together. What we did was recharacterize, for example, the air quality in the Ascoi Bridge through new type of technology, but the technology per se was simply confirming the previous project. And again, the same type of polymeric composition plus some minimal add-on as the new technology came in and new sensitivity was kicking in through this specific technology. The data that have been analyzed in the Ascoi Bridge, in the Ascoi Urban Bridge in Bergen, was 12 times higher than compared to the reference site for this project. And in this case, also compared across the Norwegian coastline. Again, our small exercise through our mathematical modeler, try to model according to this kind of results. So the amount of plastic particles that, for example, are released from the bridge and reach the aquatic environment, there was a little bit of simulation considering the shape of the particles, the size, and their behavior into the aquatic environment. We formed a small distribution, particle distribution model, ending up in a kind of a map that is showing us about the dimension of the plastic particles, and on a later stage an expected amount of concentration in the air, in the water column, and in the sediments. This at glance something that is basically going on in terms of a dialogue and discussion across the scientific community. Scientific community that I'm happy to acknowledge here. First, the Bergen Commune for partnering for the first project, and also the members of the JPI FACTS that have contributed into the air quality and mathematical modeling part of the project. And thank you very much for your attention to this presentation.
Thank you very much, Alessio. We had estimated a bit more time for this presentation, so now we have a lot of time for questions. And we have one here.
Hello, and thank you very much for your presentation. I didn't know this was going on or has been going on. My name is Bruce Ralston, and I'm from Norwegian Meteorological Institute. I did the last presentation about road dust. We also model tire wear and its contribution. I haven't checked my numbers, but I would say 10 nanograms from tire is a very low value. I was wondering if you've compared this to other studies, because there are many other studies which have used speciation to chemical composition to identify the tire wear. How does this compare to other studies of air pollution and contribution of tires?
Yes. Yeah, the mic is on. No, the thing is we are not always expecting a large amount of plastic in the air, because remember that the density or the mass of the car tire is extremely high. So we are not expecting this to fly, and not to fly far away from the, let's say, the production area. So it's basically the road. If I understood correctly, you analyze the wastewater coming from the road, and there definitely we should have a massive amount of plastic tires, let's say, coming out from the road, but way less from the air. In terms of comparing, in the previous slide that I presented during the presentation, we basically compared something with the Tokyo area. Remember, we're talking about the air here, and also the air in the North Sea, because of the project, this GPI FACT was also monitoring the air during the cruise. And in that, again, to what we observed in the Bergen Bridge, it is 10 times higher, air versus air, and it is Tokyo area is actually 100 times higher than what we compared with the Bergen area. But I imagine that it is related strongly with the traffic, which is affecting the Tokyo area, 20 million inhabitants downtown.
Well, actually, I'm just talking about, if we focus on Danmarks Plus, as far as I could see from your plot, there was roughly 10 nanograms of tire wear in the air.
Yes.
As an average over 3 months, was it?
Yes.
In the winter. Have you compared that to other measurements, tire wear in the air?
You mean in Denmark Plus or in other areas?
Anywhere in the world?
Well, we did with the Zeppelin project. And again, I mean, basically the ratio is the same. We have a kind of a 10 times higher, and in the Zeppelin, for example, we're spanning over from 3 to 5 nanogram per cubic meters.
Okay, but one more time. There are many measurements throughout Europe where they have analyzed the contribution of tire wear to PM.
Yeah.
Yeah. How does this compare to those measurements?
Mine are a little bit lower, I would say, but it is also depending how you calculate the quantification of the car tire particles, for example, because there's also a little bit of discussion nowadays about how to characterize the molecular indicators for the tire. Traditionally, there's been only styrene and butadiene rubber calculation in order to report the quantification. Very recently, there is a new kind of a way to calculate this quantification using a multi-marker type of approach. And this one seems like having given a more clear and specific characterization. And in some cases, also let's say, it seems like the new method, at least compared to the previous one, estimate a little bit better. The previous one was overestimating the total quantity of tire particles.
Okay. Okay, thank you. We have one more question here.
Yes, thank you, Scott Randall from the Directorate. Thank you for a nice presentation, Alessio. This is important cutting-edge research that you're working on here. I have a question that's a bit similar to Bruce's question, but a little more general. So when we look at these concentrations in the air in Denmark Plus or in Bergen, these other sites that you've looked at, how does this compare to other cities in Europe or around the world? Does Denmark Plus have higher or lower concentrations than other cities around the world we're measuring? Thank you.
Well, we did like a general, comparison across the different cities, and this is basically linearly correlated to the number of inhabitants. So what you experience in the Bergen area is lower than the major capitals in Europe. Data, for example, available if you're talking about Europe with the Paris, and it is also possible to compare with the Berlin. And in there, basically, we have from 20 to 300 times higher concentration there respected to Bergen. It is also a little bit, of course, related to the air circulation in that given area. So it is not per se the simple analysis. It's also, putting in the context of the general air circulation in the urban area.
Thank you. We have one question here.
Thank you. Marit Log from the National Institute of Public Health. I wonder how high levels of PM10 did you have in the same period at Denmark's place when you measured this plastic? Yeah.
Oh, I should check the data. Sorry, I do not have in front of me. But if you are curious, please text me a message by mail, and then we'll compare also the parallel data that we recorded through the project.
Are there any more questions?